Now, in this lecture, we will find the area of triangle ABC in two different ways. In the drawing, we have triangle ABC. Side AB of triangle ABC equals to 8 units. Side AC of triangle ABC equals to 14 units. And angle ACB equals to x, and angle ABC equals to 2x, and we want to find out the area of triangle ABC. So the first method will present you the first method to find out the area of triangle ABC. Okay, so first of all, we will draw line segment AD in such way. From A, we will draw line segment AD in such way this point, the touching point between this line segment and side BC, will be defined as D. We drew line segment AD in such way that angle ADB will be equal to 2x. Okay, we draw angle side AD, line segment AD in such way that angle ADB equals to 2x. So actually, in triangle ABD, we have two angles that are equal to each other. Angle ABD equals to angle ADB. Both angles are equal to 2x. Okay, and we have a rule. Okay, we have first of all two angles that are equal to each other, both of them equals to 2x. So in triangle ABD, we have two angles that are equal to each other. We have a rule, I will call it rule number 1. According to rule number 1, if two angles are equal to each other, inside the triangle, then the sides that are in front of the equal angles are also equal to each other. So I will read rule number 1 again. Rule number 1 states that if two angles are equal to each other inside the triangle, then the sides that are in front of the equal angles, the sides that are in front of the equal angles are also equal to each other. Okay, so I will explain what rule number 1 again means. Actually, if we have triangle ABC, and we know that those two angles are equal to each other. Angle ABC equals to angle ACB, both of them equal to alpha. Then the side that in front of this angle is AB. So AB will be equal to the side that is in front of this angle, angle alpha. In other words, AB equals to AC. Again, if we know that in triangle ABC we have two equal angles, both of those two angles are equal to each other, they both equal to alpha, then in front of equal angles we have equal sides. That is to say, in front of this angle alpha we have side AB, and in front of this angle alpha we have side AC. So according to rule number 1, AB equals to AC. So the sides that are in front equal angles are also equal between them. Those two sides, AB and AC, are in front of angles alpha, therefore they are also equal to each other. That is to say, AB equals to AC according to rule number 1. Okay, so actually we can implement rule number 1 in our drawing. We have in triangle ABD, in triangle ABD we have two angles that are equal to each other. Both of those two angles are equal to 2x. Therefore, according to rule number 1, the sides that are in front those two equal angles are also will be equal to each other. That is to say, the side that is in front of this angle is AB, and the side that is in front of this angle is AD. Therefore, AB will be equal to AD. AB will be equal to AD because angle ADB equals to angle ABD equals to alpha. In triangle ABD we have two angles that are equal to each other. Angle ADB equals to angle ABD. Both of those two angles are equal to alpha. both of those two angles are equal to 2x. Both those two angles are equal to 2x. Okay, in triangle ABD, this triangle, we have two angles that are equal to each other. Both of them are equal to 2x. So according to rule number 1, the sides that are in front of those two angles are also equal to each other. That is to say, AB equals to AD. Okay, again, because of the fact that in triangle ABD we have two angles that are equal to each other, both those two angles are equal to 2x. According to rule number 1, AB equals to AD, because in front of equal angles we have equal sides. For that reason, AB equals to AD. AB equals to AD. But it is given us in the question that AB equals to 8 units. Okay, AB equals to 8 units. It is given us in the question. So from this equality we can deduce that AD also equals to 8 units. Okay, AD also equals to 8 units. AD equals to 8 units. So AD equals to 8 units. Okay, and we have a second rule, rule number 2. Rule number 2. Before I present rule number 2, I will explain what is interior angle and what is exterior angle. Okay, if we have triangle ABC, in triangle ABC, angle alpha and beta are defined as interior angles. And angle ABL is defined as exterior angle. Okay, again, if we relate to triangle ABC, angles alpha and beta are defined as interior angles, and angle ABL, this angle is defined as exterior angle. Angle ABL is defined as exterior angles. So, according to rule number 2, rule number 2 states that exterior angle of a triangle is equal to the sum of the opposite interior angles. I will read rule number 2 again. Rule number 2 states that exterior angle of a triangle is equal to the sum of the opposite interior angles. So actually, if we have triangle ABC, angle alpha and beta are defined as interior angles, and they are actually opposite interior angles in relation to this angle, and angle ABL is exterior angle, angle ABL is defined, this angle is defined as exterior angles, and angle alpha plus beta are defined as opposite interior angles in relation to angle this angle. So according to rule number 2, angle ABL equals to alpha plus beta. Okay, angle ABL equals to alpha plus beta. Because rule number 2 states that the exterior angle of a triangle is equal to the sum of the opposite interior angles. This exterior angle, angle ABL, equals to the sum of the two interior opposite angles. That is to say, angle ABL equals to alpha plus beta. Okay, again, the exterior angle, angle ABL, equals to alpha plus beta. The exterior angle, angle ABL, equals to the sum of the two opposite interior angles, that is alpha plus beta, or angle ABL equals to alpha plus beta. This angle, angle ABL, equals to alpha plus beta, that is actually the opposite interior angles. Okay? So we actually can implement rule number 2 in our triangle, because actually we have, in relation to triangle ADC, we have this angle 2x, that is exterior angle in relation to this triangle, triangle ADC. If we relate to triangle ADC, then angle 2x, that angle is exterior angle of triangle ADC. Therefore, according to rule number 2, the sum of those two interior angles, that is to say, angle DAC plus angle ACD, that is two interior angles, opposite interior angles in relation to this angle. So ACD, angle ACD plus angle DAC will be equal to the exterior angle, that is 2x. Again, according to rule number 2, angle DAC plus angle ACD will be equal to the exterior angle 2x. 2x is exterior angle in relation to triangle ACD, so the exterior angle 2x equals to the sum of those two interior angles, angle DAC plus angle ACD. So the sum of those two interior angles are equal to the exterior angle. So the sum of those two interior angles is angle DAC, this angle, plus angle ACD, plus this angle. So the sum of those two angles, angle DAC plus angle ACD, will be equal to the exterior angle, that is angle 2x. Okay, so what is angle ACD? Angle ACD equals to x. Angle ACD equals to x. So we can write down that angle DAC plus angle ACD is x equals to 2x. Okay, we substituted angle ACD by x because angle ACD equals to x. We got this equality that angle DAC plus x equals to 2x. Here we can substitute x from this equality, and we will get that angle DAC equals to 2x minus x is x. So we found out that angle DAC equals to x. Angle DAC, this angle, equals to x. Okay, this angle equals to x. So in triangle ADC we have two equal angles, and according to rule number 1, in front of equal angles we have equal sides. So in front of this angle, angle x, we have CD, and in front of this angle, angle x, we have AD that equals to 8 units. So according to rule number 1, in front of equal angles we have equal sides. That is to say, AD equals to DC according to rule number 1. So in triangle ADC we have angle ACD. Angle ACD equals to angle CAD, and those two angles both are equal to x. Okay, again, in triangle ADC we know that angle ACD equals to angle CAD. Both of those two angles are equal to x. So according to rule number 1, AD will be equal to DC. AD will be equal to DC according to rule number 1. AD equals to DC because in front of equal angles we have equal sides. So in front of this angle x we have AD, and in front of this angle x we have DC. So according to rule number 1, AD equals to DC. Okay, AD equals to DC, but we know that AD equals to 8 units. We have already found out that AD equals to 8 units. So we can write here that AD equals to 8 units. So from this equality we can deduce that DC also equals to 8 units. From this equality, we will get that DC also equals to 8 units. DC equals to 8 units. Okay, DC equals to 8 units. So actually, triangle ADC is isosceles triangle because it has two sides that are equal to each other. AD equals to DC equals to 8 units. Okay? And we have another rule, rule number 3. Rule number 3 states that rule number 3 relates to only isosceles triangles, and rule number 3 states that if you draw a perpendicular to the base of isosceles triangle, or a perpendicular to the base of an isosceles triangle, divide the base to two equal parts. So I will read rule number 3 again. According to rule number 3, a perpendicular to the base of an isosceles triangle, divide the base to two equal parts. So I will explain rule number 3. Actually, if we have an isosceles triangle, triangle ABC is an isosceles triangle. This triangle ABC is an isosceles triangle, that is to say AB equals to AC. For that reason, triangle ABC is an isosceles triangle. AB equals to AC. Then the base of the isosceles triangle ABC is BC. BC is the base of triangle ABC. So if we draw from point A a perpendicular to the base of triangle ABC, okay, so from point A, if we draw perpendicular to BC, so this is a right angle, and this is also a right angle, and if we name the touching point between the perpendicular to side BC of the triangle point D. Point D is the touching point between the perpendicular and side BC. According to rule number 3, the perpendicular AD divides side BC to two equal parts, that is to say BD equals to DC. Okay, again we have isosceles triangle, triangle ABC, AB equals to AC, and we drew a perpendicular to the base BC of triangle ABC. Then that perpendicular divides the base BC to two equal parts, that is to say BD equals to DC. Okay, so that is the explanation of rule number 3. Whenever you draw a perpendicular to the base of an isosceles triangle, then that perpendicular will divide the base to two equal parts, that is to say BD equals to DC. Okay, again we can implement rule number 3 in our triangle. We have in our drawing triangle ABD, that is isosceles triangle, because AB equals to AD equals to 8 units. Again, triangle ABD is an isosceles triangle because of the fact that AB equals to AD, and the base of triangle ABD is BD. Okay, BD is the base of triangle ABD. So actually, according to rule number 3, we have here an isosceles triangle. Triangle ABD is an isosceles triangle. According to rule number 3, if we draw a perpendicular to the base, that is BD, so this angle is 90 degrees, and this angle is also 90 degrees, and we will name the touching point between the perpendicular that is drawn from point A. The touching point between the perpendicular to the base BD will be defined as point E. Then, according to rule number 3, this perpendicular AE divides the base BD to two equal parts. That is to say BE equals to ED. Okay, so I write it down. We have triangle ABD is an isosceles triangle because of the fact that AB equals to AD. Triangle ABD is an isosceles triangle because of the fact that AB equals to AD equals to 8 units. AB equals to AD equals to 8 units. Therefore, triangle ABD is an isosceles triangle. So, according to rule number 3, if we draw a perpendicular into the base of the isosceles triangle, triangle ABD, then that perpendicular AE will divide the base BD to two equal parts. That is to say BE equals to ED. BE equals to ED according to rule number 3. Okay? Again, we have isosceles triangle, triangle ABD because AB equals to AD, and we draw perpendicular from point A to the base BD. According to rule number 3, that perpendicular will divide the base BD to two equal parts. That is to say BE equals to ED. Okay, BE equals to ED, and we define BE as A. We will define BE as A. So here BE equals to A. BE equals to A. But we know that BE equals to ED according to rule number 3, therefore ED will be also equal to A units. Okay, BE equals to ED, so if BE equals to A, then ED will be also equal to A. Okay, so now we will focus. First of all, we draw perpendicular to BD. The perpendicular to BD is also perpendicular to BC, because actually BC, if we relate to the straight line BC, D rests on the straight line BC, so therefore BD and BC are on the same straight line, therefore the perpendicular to BD is also perpendicular to BC. So we will define AE as the height of triangle ABC, and it is also the height of triangle BD, because of the fact that BD and DC are the same straight line that is BC. Okay, so we will define AE as h. AE equals to h, and h is the abbreviation for the height of triangle ABD, and it is also the height of triangle ABC. Okay, again, we have side BC, and actually BD is part of side BC of triangle ABC. So if we draw perpendicular to BD, then AE will be also perpendicular to BC, because BC and BD rest on the same straight line that is BC. Okay, BC and BD rest on the same straight line that is actually BC. Okay, so if we relate to triangle ABD, in triangle ABD, we have angle AEB equals to 90 degrees, because AE is perpendicular to BD, therefore this angle is 90 degrees. So if we have angle that equals to 90 degrees, one of the triangles angle is 90 degrees, then triangle ABD, triangle ABE is a right triangle, because it has one angle that equals to 90 degrees. This angle equals to 90 degrees in triangle ABE, therefore triangle ABE is a right triangle. Okay, again, triangle ABE is a right triangle. Triangle ABE is a right triangle because it has one angle that equals to 90 degrees. Therefore, we can implement the Pythagoras theorem in the right triangle ABE. According to the Pythagorean theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, the hypotenuse in triangle ABE is AB, so AB square equals to the sum of the squares of the perpendiculars equals to AE square plus BE square. That is according to the Pythagorean theorem. Again, according to the Pythagorean theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars, that is to say ab squared equals to ae squared plus be squared. But what is the value of AB? AB equals to 8 units. So AB squared is 8 squared, 8 squared is 64. So from equation number 1, we have AB squared, that is 64. What is the value of AE? AE equals to h according to our definition. So AE squared is h squared plus BE squared. BE equals to A. So BE squared is A squared. So in total we got that 64 equals to h squared plus A squared. Here we will subtract A squared from this equality, and we will get that h squared equals to 64 minus A squared. Okay, again equation number 1 states that h squared equals to 64 minus A squared. Okay, so in the next step we will relate to triangle AEC. Okay, on triangle AEC, in this triangle AEC, we have angle AEC that equals to 90 degrees, because actually AE is perpendicular to BD. Angle AEC equals to 90 degrees. Because of the fact that one of the angles of triangle AEC equals to 90 degrees, triangle AEC is a right triangle. Okay, triangle AEC is a right triangle. Again, in triangle AEC we have one angle that equals to 90 degrees. That is to say, angle AEC equals to 90 degrees. Therefore, triangle AEC is a right triangle. And again, we can implement the Pythagorean theorem in the right triangle AEC. According to the Pythagorean theorem, the square of the hypotenuse, that is AC squared, that will be equation number 2, AC squared equals to the sum of the squares of the perpendiculars, equals to AE squared plus EC squared. So equation number 2 is the implementation of the Pythagorean theorem in the right triangle AEC. The square of the hypotenuse is AC, so AC squared equals to the sum of the squares of the perpendiculars, equals to AE squared plus EC squared. Okay, AC squared equals to AE squared plus EC squared. But what is the value of AC? AC equals to 14 units. So AC squared is 14 squared. 14 squared is 196, equals to AE squared. AE equals to H. So AE squared is H squared plus EC squared. EC equals to A plus 8. Again, EC equals to A plus 8. So EC square is A plus 8 square. Okay, so equation number 2 states that 196 equals to A square plus A plus 8 square. But we have already found out that 8 square, according to equation number 1, equals to 64 minus A square. So we can substitute A square by 64 minus A square, because A square equals to 64 minus A square. Okay, so we will get in equation number 2 that 196 equals to A square, and we will substitute A square by 64 minus A square, plus A plus 8 square is A square, plus 64 minus 16A. Okay, in total we got that 196 equals to 64 minus A square plus A square, plus 64 minus 60 plus this plus 68, because A plus 8 square is A square plus 64 plus 68 plus 16A. So actually here we have minus A square plus A square is 0, so A square is cancelled, and 64 plus 64 is 128, so I write it down. So we got that 196 equals to 64 plus 64 is 128 plus 16A. Okay, we have here only one variable in equation number 2. So here we will subtract 128 from equation number 2, and we will get that 68 equals to 16A. Okay, 68 equals to 16A. Here we will divide the equation number 2 by 16 in order to get the value of A. So A equals to 68 over 16. Okay, we got that A equals to 68 over 16. And 68 over 16 is actually 17 over 4. Okay, we can divide the numerator and the denominator by 4, and we will get that A equals to 17 over 4 units. We found out the value of A. A equals to 17 over 4 units. Okay, but we know from equation number 1 that H squared equals to 64 minus A squared. According to equation number 1, H squared equals to 64 minus A squared. So we can substitute A squared by A squared from here. So H squared will be equal to 64 minus A is 17 over 4, so it's A squared is 17 over 4 square. We got that H squared equals to 64 minus 17 over 4 square. And here h squared will be equal to 64 minus 17 squared is 289 over 4 squared is 16. So here we will multiply 64 by 16 and then we'll divide it by 16 and we will get that h squared equals to 64 times 16 is 1024 minus 289 over 16. So in total we got that h squared equals to 1024 minus 289 over 16. 1024 minus 289 is 735. So we will get that h squared equals to 735 over 16. Here we will take a root out of this equality and we will get that h, the height of triangle ABC, equals to the root of 735 over 16. Okay? And this 735 equals to 5 times 3 times 7 times 7, 16 equals to 4 times 4. Okay? 735 equals to 5 times 3 times 7 times 7 over 16 equals to 4 times 4. The root of 7 times 7 is 7 and the root of 4 times 4 is 4. So here we will get that h equals to 7 is the root of 7 times 7 is 7 and the root of 4 times 4 is 4. Inside the root we have only 5 times 3 left. So it is actually 15. So we got that the height of triangle ABC h equals to 7 over 4 times root 15. And we have already found out that A equals to 17 over 4 units. The h is units also. Okay, so we found out that the height of triangle ABCH equals to 7 over 4 times root 15 units and the A equals to 17 over 3 units. Okay, so what is the area of any triangle? The area of any triangle equals to the base of the triangle times the height to the base over 2. This is the formula for the area of any triangle. The area of any triangle equals to the base of the triangle times the height to the base over 2. You should remember that the height must create 90 degrees with the base, otherwise it is not the height. Okay? And what is the area of triangle ABC? The area of our triangle ABC, equals to the base of the triangle. The base of the triangle is BC. and the height to the base is h. Why the height to the base is h? Because edge, that is AE, creates 90 degrees with the base BC. Therefore, edge is the height of triangle ABC because it creates 90 degrees with the base BC. Okay, so it is the height of triangle ABC equals to BC times edge over 2. What is the value of BC? The value of BC equals to, this is BC, BC equals to A plus 8, or BC equals to 2A plus 8. 2A plus 8 over 2, and what is the value of h? The value of h equals to 7 over 4 times root 15. So we can write down that h equals to 7 over 4 times root 15. Okay, so we found out that the area of triangle ABC equals to 2 times A plus 8 times 7 times root 15 over 4. So the area of triangle ABC equals to, we know that A equals to 17 over 4 units, so we can substitute A by 17 over 4, so 2 times A is 2 times 17 over 4, 2 times 17 over 4 is 17 over 2. Over 2 plus 8 times 7 times root 15 here 2 times 4 is 8, so in total we got that the area of triangle ABC equals to 17 over 2 plus 8 times 7 times root 15 over 8. Okay, so here instead of 8 we can write down 16 over 2, and 2 will be the common factor of this expression. Okay, so the area of triangle ABC will be equal to 17 over 2 plus 16, because 16 over 2 is 8, okay? 16 over 2 is 8, so we didn't change anything, times 7 times root 15 over 8. Okay, here we can move 8 to the denominator, and we will get that 2 times 8 is 16. So the area of triangle ABC equals to 17 plus 16 is 33. 33 times 7 times root 15. Again, we will move 8 to the denominator, and 2 times 8 is 16. So in total we got that the area of triangle ABC equals to 33 times 7 is 231. Okay, so the area of triangle ABC equals to 231 times root 15 over 16 square units. Again, the area of triangle ABC equals to 231 times root 15 over 16 square units. Okay, so that was the first method to find out the area of triangle ABC. So I will present you second method, second way to find out the area of this triangle, triangle ABC. A, B, C. Okay, I will present to you second method to find out the area of this triangle, triangle ABC. Actually, we have a rule number 4. Rule number 4 states that the area of triangle ABC, that can be any triangle, not necessarily our triangle, but it can be any other triangle. If we have triangle ABC and we know that the size of side AB of triangle ABC is A, and the size of side AC of triangle ABC is B, and we also know that the angle between side AB and side AC is theta. Then, according to rule number 4, the area of this triangle, triangle ABC, A is the abbreviation for area. The area of triangle ABC will be equal to A times B times sinus theta over 2. So this is actually a new formula to find out the area of any triangle. But we must know two sides, the size of two sides of the triangle and the angle between those two sides, and then we can find out the area of the triangle. So the area of any triangle equals to A times B times sinus theta over 2 square units. Okay, so we can implement rule number 4 in order to find out the area of our triangle, triangle ABC. What is the area, actually, what is the angle, what is the size of angle A? Actually, we have rule that states that the sum of the angles in any triangle equals to 180 degrees. That is to say, angle A plus angle B, that is actually 2x, plus angle C, that is x, must be equal to 180 degrees. This equality is true for any triangle in the world. The sum of the angles in any triangle in the world must be equal to 180 degrees. For that reason, especially the sum of the angles in our triangle ABC, must be equal to 180 degrees. That is to say, angle A plus angle B plus angle C must be equal to 180 degrees. So, angle A plus angle 2x plus angle x must be equal to 180 degrees. So, 2x plus x equals to 3x. So, here we get that angle A plus 3x equals to 180 degrees. Here we can subtract 3x from this equality, and we will get that the area of triangle A equals to 180 degrees minus 3x. Okay, so we found out the size of angle A. Angle A equals to 180 degrees minus 3x. Okay, after we found out the value of angle A, we can implement rule number 4 in order to find out the area of this triangle, triangle ABC, because we must know the size of two sides and the angle between them. And we have already found out the size of the angle between those two sides, that we know the size of them. Okay, so the area of triangle ABC according to rule number 4, area A is abbreviation for area, so the area of triangle ABC equals to the multiplication of the two sides, AB times AC, times the angle between those two sides, times sinus the angle between those two sides, that is actually sinus of the angle A, that is 180 degrees minus 3x, and we will not forget to divide it all by 2. Okay, so the area of triangle ABC equals to AB times AC times sinus 180 degrees minus 3x over 2. That is according to rule number 4. Okay, but what is the value of AB? AB equals to 8 units. What is the value of AC? AC equals to 14 units. Okay, so we can write down that the area of triangle ABC equals to AB is 8 units, AC is 14 units, sinus of 180 degrees minus 3x over 2. Okay, so the area of triangle ABC equals to 8 times 14 times sinus 180 degrees over 2. 14 over 2 is 7, and 7 times 8 is 56. So I write it down that the area of triangle ABC equals to 56 times sinus sine of 180 degrees minus 3x. Okay, the area of triangle ABC equals to 56 times sine of 180 degrees minus 3x. We have the following trigonometric identity that states that sine of 180 degrees minus alpha equals to sine alpha. We can implement this trigonometric identity that states the sine of 180 degrees minus alpha equals to sine alpha, because according to this trigonometric identity, sine of 180 degrees minus 3x will be equal to sine 3x. So we can write down that the area of triangle ABC equals to 56 times sine of 3x. Okay, we found out that the area of triangle ABC equals to 56 times sine of 3x. Now I will present to you rule number 5. Rule number 5 is actually the law of sines. Rule number 5 is the law of sines. So according to the law of sines, in any triangle, we can implement the law of sines in any triangle. In any triangle, so if we have triangle ABC that is not necessarily our triangle but any other triangle, and we know that the size of side AB of triangle ABC is A units. The size of side AC equals to B units, and the size of side BC equals to C units. We know that this angle is gamma. We know that this angle is beta. And we know that this angle is alpha. Then, according to the law of sines, A over sinus alpha equals to B over sinus beta equals to C over sinus gamma. So the following equality is true for any triangle. A over sinus alpha equals to B over sinus beta equals to C over sinus gamma. A over sinus alpha equals to B over sinus beta equals to C over sinus gamma. And especially this equality is true in our triangle ABC. So we actually can implement rule number 5, the law of sines, in our triangle ABC. Okay, we will implement rule number 5, the law of sines, in our triangle ABC. So according to the law of sines, in our triangle ABC, AC over sinus 2x equals to AB over sinus x. Again, according to the law of sines, the implementation of the law of sines in our triangle ABC, that I called it also rule number 5, AC over sinus 2x equals to AB over sinus x. Again, AC over sinus 2x equals to AB over sinus x. But what is the value of AC? AC equals to 14 units. So 14 over sinus 2x equals to, what is the value of AB? AB equals to 8 units. So it is 8 over sinus x. So in total we got that 14 over sinus 2x equals to 8 over sinus x. And we have the second trigonometric identity that states that the value of sinus 2x equals to 2 sinus x cosinus x. Okay, we use this trigonometric identity in order to calculate the value of sinus x. Okay, so here we will get that 14 over sinus 2x is 2 sinus x cosinus x equals to 8 over sinus x. Okay, in total we got that 14 over 2 sinus x cosinus x equals to 8 over sinus x. So here we have sinus x in this side of the equation, in the denominator of this side of the equation, and we have sinus x in the denominator of this side of the equation, so we can cancel sinus x. And 14 over 2 is 7. So in total we will get that 7 over cosinus x equals to 8. Okay, here we will multiply this equality by cosinus x, and then we will divide it by 8, and we will get that cosinus x equals to 7 over 8. We found out that cosinus x equals to 7 over 8. Here we will use the third trigonometric identity in order to find out the value of sinus x. So the third trigonometric identity states that sine square x plus cosine square x equals to 1. So we will use the third trigonometric identity, this third trigonometric identity, in order to find out the value of sinus x. So from this trigonometric identity, we will subtract cosinus square x. We will get that sinus square x equals to 1 minus cosine square x. Okay, we subtracted cosine square x from this equality, from this identity, and we got that sine square x equals to 1 minus cosine square x. Here we will take a root out of this equality in order to find out the value of sine x. So we will get that sine x equals to the root of 1 minus cosine square x. Okay, so we found out the value of sine x. Sine x equals to the root of 1 minus cosine square x. But we have already found out that cosine x equals to 7 over 8. Here we have already found out that cosine x equals to 7 over 8. Okay, cosine x equals to 7 over 8. So we can square this equality in order to find out the value of cosine square x. Okay, we will square this equality and we will get that cosine square x equals to 49 over 64. Okay, we found out that cosine square x equals to 49 over 64. So we can substitute cosine square x on this equality by 49 over 64. Okay, so we will get that sine x equals to the root of 1 minus cosine square x equals to 49 over 64. So in total we got that sine x equals to the root of 1 minus 49 over 64. Here actually we will take a common factor of 64 out of this expression, or in other words, instead of 1 we will write down 64 over 64 in order that 64 will be the common factor of this expression. We will get that sine x equals to the root of 64 minus 49 over 64. So sine x equals to the root of 15 over 64. Sine x equals to the root of 15 over 64. The root of 64 is 8. So we write it down. We will get that sine x equals to the root of 15, and the root of 64 is 8. So we found out that sinus x equals to root 15 to the root of 15 over 8. But we have already found out that the area of triangle ABC, A is abbreviation for area, the area of triangle ABC equals to 56 times sine 3x. Okay, we found out that the area of triangle ABC equals to 56 times sine 3x, and we know that sine x equals to the root of 15 over 8. Okay, so here I will present you the fourth trigonometric identity that states that the value of sinus 3x equals to 3 sine x minus 4 sine cube x. Again, the fourth trigonometric identity states that the value of sine 3x equals to 3 sine x minus 4 sine cube x. Okay, so we can use this trigonometric identity in order to solve this equation, this equality, and to find out the area of triangle ABC. So the area of triangle ABC equals to 56 times, instead of sinus 3x, we can write down this expression that equals to sinus 3x. So it is sinus 3x equals to 3 sine x minus 4 times sine cube x. So actually here we can take out sine x as a common factor of this expression. We'll take out sine x as a common factor of this expression, and we will get that the area of triangle ABC equals to 56, and as I've already told you, we will take sine x as a common factor. We take out sine x as a common factor of this expression. So after we took out sine x as a common factor of this expression, in the brackets what is left here is 3 minus 4 sine square x. 4 sine square x. Okay, so we found out that the area of triangle ABC equals to 56 times sine x. In the brackets we have 3 minus 4 sine square x. We have already found out that sine x equals to root 15 over 8. But here we have 4 minus 4 sine square x. So we will square this equality in order to find out the value of sine square x. Okay, so the value of sine square x equals to root 15 square is 15, and 8 square is 64. So we got the value of sine square x is equals to 15 over 64. Okay, so the area of triangle ABC equals to 56 times sine x equals to root 15 over 8 times 3 minus 4 sine square x equals to 15 over 64. So in total we got that the area of triangle ABC equals to 56 times root 15 over 8. In the brackets we have 3 minus 4 times 15 over 64. So actually the area of triangle ABC equals to 56 over 8 is 7. So it is 7 times root 15. Minus, we can cancel 4, and 64 over 4 is 16, and here 4 is cancelled. So we will get that is actually 15 over 16. Okay, in total we got that the area of triangle ABC equals to 7 times root 15 times 3 minus 15 over 16. Okay, here we can write that 3 equals to 84 over 16 in order to have common factor of 16 of this expression. Okay, so the area of triangle ABC equals to 7 times root 15, and instead of 3 we will write down 84 over 16. 84 over 16 is 3, so we change nothing. Minus 15. In total we got that the area of triangle ABC equals to 7 times root 15. In the brackets we have 48 minus 15 over 16. 48 minus 15 is 33. So I'll write it down. We will get that the area of triangle ABC equals to root 15 times 7. 48 minus 15 is 33 over 16. So the area of triangle ABC equals to root 15. 7 times 33 is 231 over 16. Okay, so we'll get that the area of triangle ABC equals to root 15. Again, 7 times 33 is 231 over 16 square units. So we found out that the area of triangle ABC equals to root 15 times 231 over 16, and we will check out if we found the same result according to our method number first method. In the first method, we also found out that the area of triangle ABC equals to 231 times root 15 over 16 square units. So it is exactly the same result that we found here, that is 231 times root 15 over 16 square units. Okay, so again, the area of triangle ABC equals to root 15 times 231 over 16 square units. Okay, so now I'll summarize the lecture. Actually, we wanted to find out the area of triangle ABC, and we know that AB equals to 8 units, AC equals to 14 units, this angle ABC equals to 2x, and angle ACB equals to x, and we want to find out the area of triangle ABC. Okay, so we will start with the first method. So in the first method, actually we draw line segment AD in such a way that this angle is 2x, like this angle that is also 2x, and we have rule number 1, according to rule number 1, if two angles are equal to each other, if two angles are equal to each other inside a triangle, then the sides that are in front of the equal angles are also equal to each other. So actually, if we have triangle ABC and we know that those two angles are equal to each other, then according to rule number 1, the sides that are in front of those two angles are also equal to each other. the side that is in front of this angle is side AC, and the side that is in front of this angle is AB. So according to rule number 1, AC will be equal to AB. Why? Because in front of equal angles we have equal sides. Again, in front of equal angles we have equal sides. Therefore, AB will be equal to AC. Okay, AB will be equal to AC if those two angles are equal to each other. Okay, so we actually can implement rule number 1 in our drawing. We have here in triangle ABD, we have two angles that are equal to each other. Therefore, according to rule number 1, the sides that are in front those two equal angles are also will be equal to each other. That is to say, according to rule number 1, AB will be equal to AD. Okay, according to rule number 1, because we have two angles that are equal to each other in triangle ABD, therefore AB equals to AD. But we know that AD equal to 8 units. It is given us in the question. AB equals to 8 units. Okay, AB equals to 8 units. So according to this equality, we can deduce that AD also equals to 8 units. Okay, so AD also equals to 8 units. Okay, and we have rule number 2 that talks about exterior angle and interior angles. In triangle ABC, this angle ABL is exterior angle, and those two angles inside triangle ABC are defined as interior angles, and they are actually opposite interior angles in relation to angle ABC, and angle ABL is exterior angle, and angles alpha and beta are interior angles. So according to rule number 2, exterior angle of a triangle is equal to the sum of the opposite interior angles. So rule number 2 states that the exterior angle ABL, that is exterior angle, is equal to the sum of the two interior angles. That is to say, angle ABL equals to angle alpha plus beta. Again, according to rule number 2, the exterior angle ABL equals to the sum of the angles of the sum of the interior angles. That is to say, ABL equals to alpha plus beta, according to rule number 2. So again, we can implement rule number 2 in our drawing, because we have here triangle ADC that has two interior angles. Those two angles are interior angles, and angle 2x is exterior angle in relation to triangle ACD. Okay, so according to rule number 2, the exterior angle 2x will be equal to the sum of the interior angles, that is to say, to this angle plus this angle. Again, according to rule number 2, angle DAC plus angle ACD equals to 2x. Angle DAC, this angle, plus angle ACD, the sum of those two angles will be equal to the interior angle 2x. Angle DAC plus angle ACD equals to 2x, but we know that angle ACD equals to x. It is given us that angle ACD equals to x. So here we can substitute ACD by x, and we will get that DAC, angle DAC plus x equals to 2x. Here we can subtract x from this equality, and we will get that angle DAC equals to x. So this angle DAC equals to x. Okay, so in triangle ADC we have two angles that are equal to each other. And according to rule number 1, in front of equal angles we have equal sides. Again, according to rule number 1, in front of equal angles we have equal sides. That is to say, ADC is the side that is in front of this angle, and in front of this angle we have AD. Therefore, according to rule number 1, AD equals to DC. Okay, so again in triangle DAC we have two angles that are equal to each other. Both of those two angles are equal to x. So according to rule number 1, in front of equal angles we have equal sides. That is to say, AD will be equal to DC. AD will be equal to DC. But we know that AD equals to 8 units. AD will be equal to DC, and we know that AD equals to 8 units. So from this equality we can derive that DC also equals to 8 units. Okay? DC equals also to 8 units. Okay? Then we have rule number 3 that states that a perpendicular to the base of an isosceles triangle divides the base to two equal parts. Okay, so if we have, rule number 3 states that if we have an isosceles triangle, if triangle ABC is isosceles triangle, that is to say AB equals to AC, then according to rule number 3, the perpendicular that we draw to the base of the triangle that is BC, this perpendicular will divide the base BC to two equal parts, that is to say BD will be equal to DC. Again, in a triangle, if you draw a perpendicular to the base, that perpendicular will divide the base to two equal parts, that is to say BD will be equal to DC. Okay, so again we can implement this rule number 3 in our circle because we have triangle ABD that is in isosceles triangle because of the fact that AB equals to AD, AB equals to AD, therefore triangle ABD is an isosceles triangle. So according to rule number 3, if we draw from point A a perpendicular to the base BD, that perpendicular will divide the base BD to two equal parts, that is to say BE equals to ED. Again, in the isosceles triangle ABD is a isosceles triangle because AB equals to AD equals to 8 units. If we draw a perpendicular, then that perpendicular will divide the base BD to two equal parts, that is to say BE equals to ED. That perpendicular that is called edge AE will divide the base BD to two equal parts, that is to say BE equals to ED. So if we define BE as A, then ED that equals to BE will be also equal to A. Okay, if we define BE as A, then DE that equals to BE also will be equal to A. So actually we can conclude that BE equals to A and ED equals also to A. Okay, so we draw perpendicular to the base BD, therefore this angle is 90 degrees and this angle is 90 degrees. Because of the fact that this angle is 90 degrees, triangle ABD is a right triangle because it has one angle that equals to 90 degrees. So triangle ABE, this triangle is a right triangle because it has one angle that equals to 90 degrees, and we can implement the Pythagorean theorem in the right triangle ABE. According to the Pythagorean theorem, the square in the right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in triangle ABE is AB. So AB square will be equal to AE square plus BE square. Again, in the right triangle ABE, AB square will be equal to AE square plus BE square. Okay, and we know that AB equals to 8, so 8 square is 64. AE equals to 8, so AE square is H square. And BE equals to 8, so BE square is A square. So in total we got, according to equation number 1, that H square equals to 64 minus A square. Okay, and then we relate it to the right triangle AEC. AEC, triangle AEC is a right triangle because of the fact that it has one angle that is equal to 90 degrees. This angle AEC equals to 90 degrees. Therefore, triangle AEC is a right triangle. So we can implement the Pythagoras theorem in the right triangle AEC. According to the Pythagorean theorem, in the right triangle AEC, the square of the hypotenuse, that is to say AC square, will be equal to the sum of the squares of the perpendiculars, will be equal to AE square plus CE square, will be equal to AE square plus EC square. Okay? We know that AC equals to 14 units, so AC square is 14 square is 196. AE equals to H, so AE square is H square, and EC equals to A plus 8. EC equals to A plus 8, so EC square equals to A plus 8 square. Okay, here we know that H square equals to 64 minus A square, so we can substitute H square from equation number 2 by 64 minus A square, and after we substituted H square by 64 minus A square, we have only one variable that is missing in one equation, that is A, and we solved this equation and we found out that A equals to 17 over 4 units. After we found out the value of A, we can easily find out the value of H, because H square equals to 64 minus A square, and we know that A equals to 17 over 4, so A square will be equal to 17 over 4 square. So we will find out that H square equals to 735 over 16. So H equals to 7 over 4 times root 15 units, and we have already found out that A equals to 17 over 4 units. And so we know the value of A and we know the value of H. So we can find out the area of triangle ABC, because the area of any triangle equals to the base of the triangle times the height over 2. And the base of triangle ABC is BC, and the height is H over 2. Okay? The area of triangle ABC equals to BC times H over 2. But BC equals to A plus 8 equals to 2A plus 8. BC equals to 2A plus 8, and H equals to 7 over 4 times root 15. Okay? And we know that A equals to 17 over 4. So we have all the variables inside this equality. After we solved this equality, we found out that the area of triangle ABC equals to 231 times root 15 over 16 square units. Again, the area of triangle ABC equals to 231 times root 15 over 16 square units. Okay, that was the first method to solve this question, to find out the area of triangle ABC, and the second method to find out the area of triangle ABC So in the second method, we used rule number 4 that states that according to rule number 4, the area of any triangle equals to A times B times sinus theta over 2. The area of any triangle equals to A times B times sinus theta over 2. And we actually found out angle A. We know that the sum of the angles in any triangle equals to 180 degrees. So we can say that x plus 2x plus angle A will be equal to 180 degrees. A plus 2x plus x will be equal to 180 degrees. And we found out that angle A equals to 180 degrees minus 3x. Angle A equals to 180 degrees minus 3x. So we can use rule number 4 in order to find out the area of this triangle. According to rule number 4, the area of triangle ABC will be equal to AB times AC times sinus 180 degrees minus 3x over 2. Again, the area of triangle ABC will be equal to AB times AC times sinus 180 degrees minus 3x over 2. And we know that AB equals to 8 units and AC equals to 14 units. Okay, so we can substitute AB by 8 and AC by 14. And we have here sinus 180 degrees minus 3x. And we know that sinus, okay, so the area of triangle ABC equals to 56 times sinus 180 degrees minus 3x. Okay. And we know that sinus 180 degrees minus alpha equals to sinus alpha, so the area of triangle ABC will be equal to 56 times sinus x, because sinus of 180 degrees minus 3x equals to sinus 3x according to this equality. And then we have rule number 5. That is the law of sines. We can use it in any triangle. According to the law of sines, A over sinus alpha equals to B over sinus beta equals to C over sinus gamma. Again, according to the law of sines, A over sinus alpha equals to B over sinus beta equals to C over sinus gamma. Okay, so we can implement the law of sines, so rule number 5. In our triangle, the implementation of the law of sines in our triangle will be the following one, that AB over sinus x equals to BC equals to AC over sinus 2x. Again, AC over sinus 2x, AC over sinus 2x will be equal to AB over sinus x. Okay, AC over sinus 2x will be equal to AB over sinus x. But we know that AC equals to 14 units and AB equals to 8 units. So we can substitute AC by 14 and AB by 8. And we we know that sinus 2x equals to 2 sinus x cosinus x. Okay, so we can write here 14 over sinus 2x, that is 2 sinus x cosinus x, equals to 8 over sinus x. We can cancel sinus x because we have sinus x in the denominator of both sides of the equation. And after we cancel sinus x, we found out that cosinus x equals to 7 over 8. And then we have the following trigonometric identity that states that sine square x plus cosine square x equals to 1. From this equality we got that sine x equals to the root of 1 minus cosine square x. We know that cosine x equals to 7 over 2, so cosine square, if we square this equality, we will get that cosine square x will be equal to 49 over 64, so we can substitute cosine square x by 49 over 64. After we substitute cosine square x by 49 over 64, we got that sine x equals to root 15 over 8. So, and we know that the area of triangle ABC, we've already found out that the area of triangle ABC equals to 56 times sine of 3x according to rule number 4 that presented the area of the triangle. So the area of triangle ABC equals to 56 times sine of 3x. And we've already found out that sine x equals to root 15 over 8. And we have the fourth trigonometric identity that states that the value of sine 3x equals to 3 sine x minus 4 sine cube x. We can use this trigonometric identity in order to find out the value of sine 3x. So we substitute sine 3x by this expression, and then we found out that the area of triangle ABC equals to 56 times sine x times 3 minus 3 sine square x, and we know that sine x equals to root 15 over 8, so if we square this equality, we will get that sine square x equals to 15 over 64. So the area of triangle ABC, we can substitute sinus x by root 15 over 8, and we can substitute sinus square x by 15 over 64. And we found out that the area of triangle ABC equals to root 15 times 231 over 16 units, exactly as we found in the first method. Okay, so that is the solution to the question that the area of triangle ABC equals to root 15 times 231 over 16 square units. Again, the area of this triangle, triangle ABC, equals to root 15 times 331 over 16 square units. Okay, thank you very much.